Ladies and gentlemen, now we will start the 7th lecture of the Improve phase. During the lecture, the following topics will be covered: Improve process balancing, production leveling Hijunka. To improve process balancing, collect the necessary data, and determine the entire customer demand, the available net time, and the net capacity per process step. Calculate the tack time. The tack time describes the time span in which a specific process step or sub-process has to be completed if the product is to be delivered in line with customer requirements at the end of the overall process. Tack time is equal to available production time divided by the number of units to be produced according to customer demand. Identify the bottlenecks process step with the lowest exit rates represents the most time-consuming operation. The bottlenecks are determining capacity, causing long lead times, high inventories of finished goods, and high inventories of unfinished products, or WIP. Improved process balancing is used when system overall lead time suffers because work or task is improperly balanced. In the shown graph, the black bars represent the non-value-added time, while the red bars represent the value-added time for each process. The tack time is calculated and shown. P5 is the bottleneck, and it will delay the whole process. Improved guidelines. Minimize movement. Stabilize lead time first, before trying to minimize it. Maximize resource efficiency. Minimize number of process steps. Balance tasks and labor across process steps. Maximize space utilization. Minimize tact variance. Minimize non-value-added, conveyance, standby, and motion wastes. Minimize volume variability, combine product category demand. Maximize flexibility to allow for product introductions and discontinuations. Use training and continual reinforcement to maintain gains. An example for the improved process balancing. In the shown graph for the process steps, the individual process steps are not balanced. To improve the process balance, non-value-adding time has been reduced. Process step 2 and 3 have been merged. Parts of step 4 are done in step 5. The first process to make unit ABC contains a particular machine, which is scheduled to run 24 hours per day on 3 shifts. Each shift gets 30 minutes break. There is a mandatory quality review at the start of each shift that lasts 20 minutes. Forecast daily demand is 40,000 parts per day. Calculate the tack time. Please pause the lecture and solve the exercise. Available production time is equal to 24 times 60 minus 3 times 30 minus 3 times 20, which is equal to 1,290 minutes per day and equal to 77,400 seconds per day. Number of units to be produced according to customer demand is equal to 40,000 parts per day. Tack time is equal to 1.935 seconds per part. There are another 4 processes in the work cell dedicated to only unit ABC. Each process has same demand and available work time resulting in same tack time. The cycle time data was found using Historical production data of parts only include downtime, but only when the processes were scheduled with operator. Find the bottlenecks and areas of excess capacity by making analysis for the provided quantitative data and prioritize activities for improving the process balancing. Please pause the lecture and solve the exercise. Process 1, taking much longer than tack time. Process 2, exceeding the tack time, probably a lot of waiting, and the excess capacity can be filled by absorbing some of the work from Process 1 and/or Process 4. Process 3 and 5, very close to meeting tack time, not a focus area, but possibly some best practices and application of lean tools can improve these loading rates. Process 4, taking longer than tack time. Again, overtime is probably used or there are late deliveries and unhappy customers. Apply lean manufacturing principles and try to alleviate workload to Process 2 or others that may be able to be improved to absorb some of the workload. Examine all the specific activities occurring in each process. Time studies, motion studies, and other lean tools often provide most of the ideas for improvement. Run studies to determine the potential cycle time improvements. There is most likely not much that can be done to change the tack time. Focus on improving the cycle time, production rate. Improving the cycle time, even in non-constrained operations, is desirable, but the top priority is relieving constrained operations. The following steps have been done. Visual management tools added to improve consistency of units produced. Standard operating procedures, SOP, and training were done for all operators. SMED activity was done on all operations, with focus on Process 1. Point-of-use tooling and shadow boards were implemented. Kanbans were established for materials. Some steps in each process found no longer necessary. The machines in a couple operations received upgrades and overdue minor rebuild and were added to a TPM program. On lights were added as communication signals. 5S event held with key stakeholders. After process balancing, the cycle time per unit is almost equal or less than the tack time. Now, the processes are balanced. Please download the educational video from the resources Process Load Balance, sigmaxl.mp4. Hijunka is a Japanese term to describe production leveling. The distinction between leveling demand and production leveling is important because we cannot control demand. What we can control is the rate of workload, information, material, raw good, finished goods, and fulfillment, or actual production, enters the operation. Suppose an operation where small parts, 11A, medium parts, 9B, and large parts, 7C, are made. A classical batch production schedule looks like this. Although required forecast is met, but this is not Hijunka. If demand for C increases, customer has to wait till next Friday. To satisfy customer for C, the schedule must be changed. This creates an overburden on the employee overtime pay, and instability in the system. If the demand for C falls, then more C parts will be produced than the customer needed. So, he has overproduction. If a defect in A parts was on hour 5, this means we have already produced 4 hours of defective products. In this example, the forecast requirements are again satisfied. The production of A, B, and C is dispersed throughout the week. This creates a stable and predictable production schedule, less burden on the employee, fewer overproduction, and the ability to fulfill demand during times of uncertain customer demand. See this as a junka. The demand schedule for an item is listed in the table. Please assign the production levels per week for the item to the production mill using the production leveling. Please pause the lecture and solve the exercise. For the first 4 weeks, we will calculate the average demand and assign the result to the weekly level production. For the first 4 weeks, the week level production will be 4,354. We will do the same for the next 4 weeks. The week level production will be 4,217. And by doing the same for the last 4 weeks, the week level production will be 4,082. The graph illustrates the relationship between the demand and the week level production for the 12 weeks after production leveling. Unlevel production. The line makes blue, red, and white cars. The blue cars, largest demand, are made early in the week, Monday, part of Wednesday. There is a changeover, and the red cars are made Wednesday to Friday morning. After another changeover, the white cars, smallest demand, are made Friday afternoon. This typical unleveled method creates 4 problems. 1. If the customer decides to buy the white cars early in the week, the plant is in trouble. 2. The risk of unsold goods that must be kept in inventory. 3. The use of resources is unbalanced. 4. There is an uneven demand on upstream processes. The bullwhip effect refers to increasing swings in inventory in response to shifts in customer demand as you move further upstream supply chain. Research indicates a fluctuation in point of sale demand of plus or minus 5%, which will be interpreted by a change in demand of up to plus or minus 40%. Mixed model level production. By reducing the changeover time and other lean methods, the plant is able to build the tractors in any order it wants to on its mixed model assembly line. Benefits: 1. Flexibility. 2. Less inventory. 3. Balanced resources. Hijunka, tortoise, and rabbit analogy. The slower but consistent tortoise causes less waste and is much more desirable than the speedy rabbit that races ahead and then stops occasionally to doze. The Toyota production system can be realized only when all the workers become tortoises. Thank you, and see you in the last lecture of Improve phase.